the user has been assigned to manage and propose the next year grant lines of the Environmental Department. To do so, he wants to use the platform to evaluate how certain refurbishment actions could affect the city structure when applied to a large amount of buildings. Navigating through the 3D environment, powered with energy data from the corresponding urban energy model, the user interacts with the analysis features included in the platform, searching for a significantly poor energy performing group of buildings. He begins with an outer zoom and targets one of the most energy demanding neighborhoods. Zooming into this area, and by filtering, the user highlights the worst performing buildings. Now, the user chooses a section of the city including a significant amount of colored buildings. After targeting the test area, a plan is created to perform the evaluation, and a significant amount of around 100 buildings are aggregated to this recently created plan. Once the buildings have been included in the plan, it is time to set up the project. Historically, funded action lines have usually been those focused on windows and boilers. Therefore, he creates projects headed in this direction. The first of the projects will simulate the change of glass and frame of all windows in the area. The second project simulates the renewing of boilers inside households for new, more efficient ones. He uses the improvement tool based on EECITIES, where these common options are reflected, and by just 3 simple steps, these improvements are automatically applied to all the buildings within the plan. The user notices that energy demand is very high, and he decides to add a new project in which the installation of solar panels might also be a potential action to be granted. After a last check on the list of projects and outputs of each solution, the user moves to the multi-criteria decision-making tool, where he will be able to perform more detailed comparisons with the outputs of each project. The user discards the baseline situation, placed by default into the comparison by the platform. He has also added a user indicator. This is the foreseen funding amount. The knowledge from previous years that some actions are more attractive allows the user to set certain values on this new indicator. This is very useful because the budget line amount will more likely be different for each action to grant. The technician sets both the weight and the threshold of the carbon dioxide emissions as the most important of all. This is because when the grants are published, they get a lot of attention from the media. Results show that renewing boilers is the most effective option against carbon dioxide emissions. But now the user wants to make a point, and he would like to promote actions reducing the total energy demand rather than consuming with more efficient systems. He sets a new analysis removing all the indicators but energy demand. With a single indicator to compare, there is no need to adjust the weight, and the threshold is set on 500 kWh. This new analysis shows that improving windows is, by far, the best option. The user feels satisfied because he is positive that passive measures will provide, at the long term, a better benefit for the environment. As a final test, the user goes back to the neighborhood view within the 3D model and checks how aggregated figures have changed due to the projected interventions. Finally, the user prints out some figures and collects some significant screenshots that will help him support his final report. He is going to balance the budget between both lines of actions in his proposal.